reaction of phenol with sodium hydroxide. Oh. So when you react phenol with sodium hydroxide, all you need to do is replace the hydrogen with sodium. All right, so that is it. So all you need to know is for phenol, we are just interested in you knowing the reagent and the product. So once you react phenol with sodium hydroxide, you are going to get sodium phenoxide. All right, that's how it is named. So the only thing that happens, you replace the hydrogen with sodium. All right, so that's one reaction of phenol that you should know. The second reaction of phenol is with aqueous bromine, right? Same thing as bromine, water. For the first one, the sodium ion of sodium hydroxide is displacing the hydrogen. That is why you have this sodium here.
Sure. So you have to show the minus and the plus.
It is charged. But I don't think you should lose any marks if you just put ONA.
Right.
Yeah. Right. So for these, no more mechanism. The only two mechanism in this section is nitration and halogenation. For these, just ensure you remember the reagents and the products that will be produced. This part. Right. For this one, we're going to get 2, 4. All right. What would be the name? Let me see if I can tell me. What would be the name? What would be the name of it?
Say 2,4,6 tribromophenol.
Right. Two, 4, 6 tribromo. All right, with this for observation, one, bromine water is decolorized. Two, white precipitate is formed. And 3, it will smell of antiseptic, or you say antiseptic smell. All right, those are the 3 observations that you should know.
Sir, could you repeat number 2? The
Number
reaction,
2,
sir? The reaction for number 2.
in terms, sorry, someone was mentioning this, they're correct. You use 3 moles of bromine. So for the observations, the bromines, this bromine here, it is going to be decolorized. The 2,4,6 tribromophenol, that is the white precipitate. All right, it has an antiseptic smell.
So I was just wondering where the 3 bro, that's right. And the 3.
Right, yeah, so that is, I put the 3 in front of it. You should get this as well. All right, but the major part of the reaction is this, or the major product is a tribromophenol. And for this, it is this sodium phenoxide. All right. So there are 3 reactions of phenol, well, 4 that you must know. These are the first 2. All right, so if you haven't finished writing, just take a screenshot for me. All right, I'm going to clear the board now. Yes, the 3 HBr is a part of it. That is only module 1. All right, so the third reaction of phenol is with acyl chloride. And the example we're going to use, it is called ethanol. So this is just an esterification reaction, except that it's not a carboxylic acid. So remember, in a carboxylic acid, you would have the OH here. So what is going to happen? The Cl and the H are going to combine, right? So we are taking off the H off of the phenol. So you're left with O. Then we're taking off the chlorine, all right? So the carbon here is going to be attached to this oxygen. All right, so that is it. And this is phenyl ethyl know it. So acyl chloride is just like an esterification reaction. You are taking off the chlorine, you are taking off the hydrogen from the phenol. Just put the oxygen where the chlorine was. So remember the chlorine was here, that is where you put the oxygen. All right, and that is it. So that's phenol with acyl chloride. So that's the general name for this type of compound, acyl chloride. It's basically a carboxylic acid in which the OH is replaced with chlorine. So let me just write that. Here, acyl chloride. All right, this compound is formed simply. You take off the chlorine off of ethanol chloride. All right, so take off chlorine, you take off the hydrogen off of phenol. You put the oxygen of phenol where the hydrogen was. All right, that's how we got this compound.
Sir,
Yes, go ahead.
so the other product is HPL?
Right.
Okay.
Right, so those are the three for phenol. For now, there is one more I'm going to show you. All right, so take a picture. I'm going to clear the board. You should also know this reaction as well. Reduction of nitrobenzene. For this reaction, we use tin, and HCl. And you will get amine. All right. So to go from nitrobenzene to phenylamine, you will use tin and HCl. Ensure you know all of your reagents for these reactions. All right. So we're going from nitrobenzene to phenylamine. All right. All right, so for phenylamine now, we have a particular reaction that I want to look at. Well, we have to look at. So this is a reaction of phenylamine that you must know. For this reaction, you are going to react the phenylamine with nitrous acid. So HNO2 is nitrous acid. So we are using nitrous acid and not nitric acid. So it's nitric acid, sorry, nitrous acid and hydrochloric acid. For this one, the temperature must be really cold. All right. In the study guide, it says below 10. Other sources say below 5. All right. So it must be cold. And what you are going to get, you're going to have a nitrogen compound. Well, the nitrogen atom, you're going to have a triple bond, nitrogen and Cl. So just remember this structure. All right, so for some reactions, they just have reagents and not a particular condition like temperature or catalyst. So for this one, you must remember the temperature and the reagents. So for the nitration of benzene, you must remember the temperature as well. For nitration of benzene and for this diazotization reaction, you must remember the temperature as well. Not -5. It must just be below.
So you meant halogenation or not nitrogen?
Sorry, it must be below 5 degrees Celsius. All right.
Sir, you said we should remember the temperature for nitration reaction.
Remember, nitration was 50 to 60.
Oh, okay. So
Yeah.
1 hour.
Yeah, man. On this compound here, with the nitrogen triple bonded to nitrogen, is called the diazonium salt. All right. It is called diazonium salt. All right. So the name of the reaction is diazotization. So phenylamine with nitrous acid and hydrochloric acid, we are making a diazonium salt. For these reactions, just study the reagent and the product. All right. It is the main product. You will get water as well, but that's not important. All right. So it's basically the main product we focus on. Right. That is where I'm going now. All right. So for phenylamine, we are going to form a diazonium salt. Now, if you remember, I said that we have a fourth reaction of phenol. This book says below 10, the study guide. It says way below 10. All right, so if you put below 10, below 5, that's okay because the temperature it must be low. So when you use different sources, it will vary slightly, not by much. Yeah. All right, so the final reaction now that we are doing is coupling. And it is going to be a reaction between our diazonium salt and phenol. When we're doing this one, we draw it sideways generally. All right. So in this one now, we're basically going to join up the phenol with the diazonium salt. So all you need to know to do is draw the structure and remember your reagents. So after coupling, you will have nitrogen, double bond, nitrogen. You see this salt here, we're going to attach it to carbon number 4 of your phenol. All right, it goes to carbon number 4. All right. This compound here, where you join up phenol with the diazonium salt, it's an azo compound, or we say an azodie. It's an azo compound, or we just say azodie, because it is actually a dye. All right, so it is a brightly colored compound. Color is orange. All right, so all right. It's an orange color. All right, so let's just look back at the reactions that we did. And because we're going to work some past paper with benzene. So we should know the nitration of benzene, in which we used sulfuric acid, nitric acid, 50 to 60 degrees Celsius. We looked at the halogenation of benzene, in which we use FeBr3 as the catalyst. We looked at what else? For phenol now, we looked at the reaction of phenol with sodium hydroxide. You get sodium phenoxide. We look at the reaction of phenol with acyl chloride, specifically phenol chloride, and you get your ester, phenyl ethanoate. And we look at the reaction of phenol with bromine. You get the 2,4,6-tribromophenol. We said that compound, it's a white precipitate, has an antiseptic smell, and it decolorizes bromine. And then for nitrobenzene, we can reduce it to phenylamine using tin and HCl. For the phenylamine, it can form a diazonium salt if we react it with nitric acid and HCl at low temperature. All right. And then finally, we have our coupling reaction between the diazonium salt and phenol, which we get our azodie. All right, so now we are going to work a past paper question.